Homework 1.4, section complex numbers, video 7, homework due May 16, 2020. Okay, now we're in the last video for homework 1.4. I didn't want the previous video to get into the 15 and 20 minute mark, so we cut it off and we'll do the second half of the video here. You may have noticed from the previous video that I did erase the previous problems and move the ones that were on the right side of the board over here to give me more space. I originally set it up that way so that we could allude to the previous problems to help solve these, but we have the previous video so you can go back and look at them if necessary. So let's simplify all of these square root expressions, all of which have negative radicands, and as a consequence, all of which are going to invoke this rule. So let's start with simplify the square root of negative 4. Now, there are two ways to attack this. One is the straightforward approach, and the other one is a little more elegant. By the end of this example, I'm sure you're going to choose the more elegant approach. To do the square root of negative 4, the issue is not the 4. I know the square root of 4, it's 2. The issue is the negative sign. So how are we going to deal with the negative sign? The answer is take advantage of something we already have established. If you see a square root of negative 1, change it to an I. I currently do not see a negative 1. I see a negative 4. But any negative number can be written as a positive number times negative 1. So for example, I could write negative 4 as 4 times negative 1. And what's the advantage of that? If I split up the square root across this product, which is kind of like a distributive property that works most of the time. There's one exception, and if we run into it, I'll show you what it is. But if I distribute the square root across the product, I get the square root of 4 times the square root of negative 1. And I know the square root of 4, it's 2. Oh no, what do I do with the square root of negative 1? Well, if you see square root of negative 1, change it to I. I see a square root of negative 1. I'm going to change it to an I. And now it just says 2 times I, which is more succinctly written as 2I. So that wasn't too bad. But you may already be thinking, I don't have to do all that. Can't I just stick an I in the answer? In other words, the square root of 4 is 2, so for the square root of negative 4, can't I just stick on an I to the 2? Anytime in math, if you speculate a shortcut, you should give it a trial run before you say that will work all the time. So for example, if you think you can square root a negative number by simply square rooting a positive number and then sticking an I on it, let's pose one more square root of a negative number problem, like the square root of negative 49. Go ahead and fast forward all the way over here to what we think is the answer and see if we're correct. So based on the first example, what would you speculate that the square root of negative 49 would be? Well, the square root of 49 is 7, so let's speculate that the square root of negative 49 is 7i. But let's justify it to make sure our shortcut works. It's going to work. The rule that we're taking advantage of is this one, so we have to expose the negative 1 under the square root. And we can do that by writing the negative 49 as 49 times negative 1 and then distributing the square root. So this is going to run the exact same course as the previous example. The only difference is we had a 49 instead of a 4. So let's stick that feather in our cap, so to speak. If you square root a negative number, it's the same as square rooting a positive number. You just stick an I on the answer because of this. So the square root of negative 4 is 2i. The square root of negative 49 is 7i. I'm going to call some answers out, and even though I can't hear you, I'm going to call some problems out. And even though I can't hear you, I'd like to see if you can just verbally call out the answer really quickly. Go ahead. It doesn't matter if anybody's listening or watching. So what do you think the square root of negative 25 is? The square root of negative 25 is 5i. What about the square root of negative 100? The square root of negative 100 is 10i. What about the square root of negative 729? The square root of negative 729 is, I don't know, but it's got an I on it. Sometimes the issue is not the negative. Sometimes the issue is the number. So for example, if you wanted to know the square root of negative 729, you should probably get out a calculator and square root 729. And if you do that, you get 81. Wait, that's not right. If you do that, you get 27. but it was the square root of negative 729, so it's 27i. Don't be afraid to use a calculator. Calculator. Okay, that not only is written poorly, it's also spelled badly. But sometimes you just have to get out a calculator to do the bigger square roots. But the moral of the story in the first example is when you squared a negative number, you just do business as usual, but stick an I on the answer. Makes some square roots a lot easier. All right, so let's take a look at the second example. Simplify 3 times the square root of negative 20 plus 7 times the square root of negative 5. Needless to say, our first objective should be to clean up the square roots. So let's start with the square root of negative 20. Wait, didn't we simplify the square root of positive 20 earlier? We did. And if we had that up on the board, we could just capitalize on it. But let's pretend we can't take advantage of that. When you simplify a square root, the objective is to split it into 2 square roots, one of which you can answer. Now, we can split the 20 into 4 times 5 because I know the square root of 4. But what about the negative? When you're splitting a number to square root and that number is negative, you should stick the negative on the part that you can square root. I can square root the 4. It will pick up the negative. Why? Because I know how to square root a negative now. In fact, the square root of negative 4 is 2i. So when splitting up a number to square root, if the number is negative, stick the negative on the part that you can answer so that you can do it. So negative 4 square rooted is 2i, and then we don't know the square root of 5, so we're stuck with that. We'll embed this result in the problem. In fact, let's go ahead and embed it right now. By embed it, I mean put it back into the problem. So instead of 3 times the square root of negative 20, we will have 3 times 2i squared of 5. Oh, we have to do the other one as well. So let's get that set up. Plus 7 times something. So let's take the square root of negative 5 and do something with it. Well, shoot, I can't even split the 5. Well, I guess 1 times 5. But remember, the whole purpose of splitting this is twofold. Number one, to try to square root a piece of it, but I can't do anything with a 5. But the other one is to also deal with the negative. So at the very least, all I can split a 5 into is 5 times 1. We'll put the 1 first because I know it's square root. And then the negative goes with the one I can do, which is the square root of 1, which is now the square root of negative 1. But what's the square root of negative 1? If you see a square root of negative 1, change it to I. So this becomes I times the square root of 5, which looks funny because normally an I is after a square root, and I should have mentioned that up here. Excuse me, normally an I is after a number. The exception is when that number is a square root. It's not common to see an I written after a square root, but rather in front of, because if you were to write it after, you might accidentally slide it inside the square root where it doesn't belong. So the square root of negative 5 barely simplifies into I times the square root of 5, so let's put that over here. Keeping in mind the order of operations, we just did the square root, or at least we did them the best that we can. Now it's time to multiply. Don't overthink it when you're multiplying. This first term is 3 times 2 times I times the square root of 5. And although I can't multiply all of it together, I can multiply 3 times 2. Leave the I, leave the square root of 5. The same thing here, except the number in front of the I is a 1. 7 times 1 is 7. Really all I can do here is just write it all next to each other. And then take a look at this big mess and go, can I do anything with it? Well, when it comes down to adding, the rule is you can only add like terms. Which basically means, except for the numbers in front, everything else should match. Does everything after the 6 and 7 match? Of course it does. I designed it that way. So if we have 6 of these plus 7 of these, we will get 13 of those. Specifically, 13 I squared of 5. So with the exception of turning the square root of negative 1 into an I, it's business as usual. Correct order, multiplying, adding, and combining like terms. All right, let's take a look at this last one. We can actually accelerate this one a little bit because even though we haven't done the square root of negative 12 yet, we have done the square root of 12. It's not on the board, it must have been in the previous video. So what would we do with the square root of negative 12? Well, forget the negative for a second. For the 12, we'd split it into 4 and 3. But remember, when you're splitting a square root of a negative, the negative goes on the number that you can square root. So the negative will go on the 4, because I know the square root of negative 4 is still 2i. So let's embed that into the problem. So instead of 6 plus the square root of negative 12, we'll have 6 plus 2i times the square root of 3. Now this is all still over 2. And remember the rule for simplifying a fraction. You can only reduce parts of multiplication problems. You cannot reduce parts of addition problems. And remember the workaround. When you're trying to reduce in a fraction, but the top is an addition or subtraction problem, you can reverse the addition process by splitting this back into 2 fractions with a common denominator and putting each half of the numerator over its own denominator. So we can write 6 over 2 plus 2i squared 3 over 2. But plus is no longer an issue in either fraction. We can reduce each one however we see fit. 6 over 2 is 3. In the second fraction, the 2's cancel because the 2 on top is part of a multiplication problem. It's okay to cancel in a fraction, and that leaves us I times the square root of 3. It takes a little getting used to simplifying expressions with square roots of negative numbers, but as long as you remember old rules, like how to deal with fractions and square roots, and new rules, if you see a square root of negative 1, change it to I, you can tough it out. I promise you can. In the homework for 1.4, you should look at the following problems. 1, 2, 3, 4, 5. I know that seems backwards. Why is the last video talking about the first problems? I guess when I built the homework assignment, I could have put these problems towards the end. C'est la vie. Alright, so that concludes the rounds of videos for homework 1.4. I will be making a series of videos for every single homework assignment. I will try my best to keep them between 5 and 10 minutes. Don't be surprised if on occasion they do go beyond the 10-minute mark. I get the feeling this is one of them. Yep, we're at 12 minutes right now. All right, if you have any questions, you know how to get a hold of me. And keep in mind that this homework is due on the 16th. That's this Saturday at midnight.